Welcome to my channel once again.
Dr. Asadi Srinivasulu.
Machine learning techniques for imagery classification.
We see limitations of single layer perceptron. The reason is because the classifier in XOR are not linearly separable. You cannot draw a straight line to separate the points 0, 0, 1, 1 from point 0, 1, 0, led to invention of multi-layer networks. Importance of multi-layer perceptron. Multi-layer networks solve the classification problem for nonlinear sets by employing hidden layers. So whose neurons are not directly connected to the output. So multi-layer perceptrons are useful in research for their ability to solve problems stochastically, which often allows approximate solution for extremely complex problems like witness approximation. MLP uses backpropagation and a supervised learning technique. Since there are multiple layers of neurons, MLP is a deep learning technique. MLP is widely used for solving problems that require supervised learning, as well as a research into computational neuroscience and parallel distributors. Pre-activation presented by A, it is a weighted sum of input plus the bias. Activation represented by H. Activation function is non-linear function. Activation function is an activation function is a function that is added in an artificial neural network in order to help the network learn complex patterns in the data. When comparing with a neural-based model that is in our brain, the activation function is at the end. And deciding what needs to be fired to the next neuron. Backpropagation is an algorithm used to calculate derivatives quickly. ANN used GROW as a learning algorithm to compute its gradient descent with respect to weights. Next, the algorithm gets its name because the weights are updated backward from output. Gradient descent is the first order initial optimization algorithm for finding a local minimum of differentiable function. Gradient descent is an optimization algorithm for finding a local minimum of differentiable function. Gradient descent is simply, you can call it as so functions parameters, that is coefficient that minimizes a cost function as far as possible. We see the diagram learn gradient descent like gradient descent, x-axis weight, y-axis cost, and the derivative of cost, you can call it as initial weight and the incremental step gradient. See, what are the use cases of deep learning? Deep learning use cases, who are the using the worldwide? Used for knowledge discovery and predictive analytics. Includes, say, example, Google uses deep learning to build powerful voice and image recognition algorithms. Netflix and Amazon use deep learning in their recommendation engines. And MIT researchers uses deep learning for predictive analytics. Now see the diagram, especially deep learning industries, agriculture, healthcare, financial services, insurance, manufacture, retail industry, research. These are the deep learning use cases especially face unlock in smartphones, selfie filters, networking, cap booking, Hey Siri, Google, personalized marketing, Gmail spam alerts, Play Store recommendation, online food delivery portals, etc. So this is a deep learning process. Input layer 1, L1, hidden layer L2, hidden layer L3, hidden layer L4, output layer L5. You may get doubts, sir, how many we can use? Input layers and hidden layers. As many as required for your problem in order to get the good results you can use. And W stands for weight. X1 to X3 and so on, followed by the XP. These are the input layers. Then hidden layers, L2, hidden layers L3, hidden layer L4. Final output with the red color, L5, Y0 to Y1 and so on, Y9. So this is a deep learning process. If you see deep learning workflow, lots of labeled data or unlabeled data you are taking as input to the system. Training set under validation test. Training set learn deep neural network. Validation set for validating the data. Then pre-processing of the data set. Adjust parameters, network architecture, etc. We see deep learning process. I'm taking the year 1990s, how this neural networks works, and nowadays deep learning neural networks, how it is working. We see number of nodes is nothing but neurons here. It leads carry signals from one node to another, boosting or damping them according to each link's weight. Whereas the deep learning neural network, so we are taking as an input layer and identify light dark pixel value. See, I'm taking one scientist image as input to the system. This first level input layer takes the data, it divides into number of pixels, that is called identify edges, then identify combinations of edges, identify features, then identify combinations of features, then output layer gives, oh, he is a George. That is the learning, deep learning process. There are three important algorithms: deep neural networks, convolutional neural networks, recurrent neural networks, providing a link for classification and forecasting models, feature extraction and classification images by using a convolutional neural networks, and for sequence of events, language models, time series data, we are using recurrent neural networks.
Thanks for watching. Please subscribe.
Supervised models, unsupervised models. Supervised models are convolutional neural networks, classic neural networks, and recurrent networks. Unsupervised learning, self-organizing maps, Boltzmann machines, pattern networks. So DNN can perform classification, deep neural network, prediction, and time series. Whereas CNN can perform three: prediction and time series prediction, computer recognition, vision, and classification. RNN and LSTM, recurrent neural network, long short-term memory. It uses prediction and time series prediction and classification. This means CNN gives you complete image classification, especially.